Clean Sky and Eco-Design, more than just a title, a vision too, and already a success story. Since 2008, the Eco-Design Partnership has been implementing new sustainable process guidance, production and recycling concepts as part of the European Union's Clean Sky Joint Technology Initiative for civil aviation. The goal, ecologically efficient aircraft and thus a sustainable approach to Earth's finite resources. The EU requirements in this field are clear, for example in the White Paper on Smart and Green Transport and the Eco-Innovation Initiative. The Eco-Design Integration Development on the Clean Sky Initiative provides European aircraft manufacturers and their suppliers with the appropriate platform by giving developers and designers assessment methods and criteria in order to make sustainable and competitive aviation stronger in the future.
The fact that we work together, all the European aerospace industries, eliminate the need that the effort will be individual and it's a cooperation. And the fact that all the companies, the aerospace company, give the best of them, and they give their ability in R&D and the ability in developing structures, and it's a synergy between all the companies. And I find it, and the management of the eco-design project is such that it's a win-win situation that all of us give us our best and get the best of the others. And the cooperation is something which is remarkable in this project.
An aeroplane is in service for 25 years on average, a generation. Scrapping that from today's point of view is simply a complete waste. Eco-design, in other words, sustainable, ecological, social and economic use of all the aircraft life resources is one of the cornerstones of the Clean Sky Initiative. Eco-design demands a recycling scheme in accordance with modern end-of-life management. For greener aviation parts, new materials and advanced processes are consolidated into life cycle inventories. These are the genes of greener manufacturing excellence as well as higher and more efficient production levels. The use strategy, maintenance and green repair are essential for next long life structures and onboard systems efficiency. To this end, via Eco-Design, a unique materials database has been developed and implemented in cooperation with all the relevant stakeholders in the industry. The developed and integrated life cycle analysis guidance tools had to abridge the expert ISO standard for life cycle assessment on the one hand. Now life cycle assessment is easier to perform. On the other hand, these guidance tools allow an assessment of the strengths and weaknesses of the industrialization scope of products and processes. This, in turn, is all summarized in formal eco-statements.
The future for the eco-design, it's that the aviation industry they already started to incorporate, to consider the environmental criteria in their decision-making of the future aircraft design, but by using these tools, by using the LSA tool and the eco-design tool and the database and also the results and all the knowledge and the experience and gained with Clean Sky One.
The eco-design partners have worked on many other technologies. In eco-design for airframe and in eco-design for systems, they have developed innovative materials and processes to increase sustainability along the whole production chain, from the emergence of an aircraft in the planning process via the development of new components and benchmarking of the technology's pathway before they are incorporated into the finished product. Reducing the economic and ecological payload, increasing the user benefit. The numerous technologies include chemical stitching. This is one of many joining techniques for composites which could be used in the future to safely join different materials. It facilitates and improves the manufacture of lightweight elements, particularly in the carbon fiber sector. The eco-design partners have come up with more than 100 ideas and innovations to date. For a whole series of them, there are now demonstrators to present a validation stage before they go into industrial production. The goal now and in the future is a reduction of buy-to-fly scrap ratio. This can only succeed by raising the quality of the materials and the use of alternative machining methods in the automation process. This alternative control surface is extremely light but still robust under flying conditions. At the same time, it is not too expensive to produce. This is also true of this carbon fiber structure. Work has been done to improve its form and the efficiency of its production process. By replacing heavy structures by lighter ones, even more fuel is saved, and as a result, their CO2 emissions are reduced. The foam used in these seats derives from recycled polyurethane on a biological basis made from renewable raw materials. It is also highly flame resistant. Refinements have also been carried out on the electrics, a set of new corrosion-resistant plugs whose manufacture is now environmentally friendly. Component made of magnesium, attractive to look at, thin and hence lightweight, but at the same time recyclable. This is also true of the new components made of thermoplastics.
We have been trying to replace some machine metallic parts. Here I've got a turbine scroll by thermoplastic reinforced with carbon fiber, and this part is done by injection molding. It was done in the frame of a call for proposal, which leader was Egmont Plastic, an SME, and this part, as you see, is very complex, but was done in one shot by injection molding. And this is a big achievement for us because we are replacing a metallic part by a composite part, which is much lighter. A lighter part means reducing fuel consumption during operation phase. And during manufacturing, it means that this part is done in one shot, with reducing the cost and the energy consumption.
Thermoplastics can be melted down, allowing them to be put back into the material cycle. Another challenge, the elimination of toxic substances from the various materials. Safety standards in the aerospace industry are extremely high. Since there has been no adequate substitute until now, anti-corrosion coatings contain chromates and cadmium. Both are poisonous and consequently need to be replaced by alternative technologies. So the eco-design scientists have been searching for alternatives, and as far as chromates are concerned, they found an answer. They're now pushing ahead with the development of advanced alternative processes.
One main achievement is working towards the removing of chromates, those hazardous substances which we definitely need to get rid of. So this is one main example, but we have also other environmental aspects to deal with, not only hazardous substances, but also reducing the energy consumption, reducing the CO2 emissions, improving recycling possibilities, especially for composites and so on. Eco-design, to me, is something which is very important for the future, and because it also enables it's a driver for improving the products at the end, and the future would be to have this culture, the eco-design culture, and embedded in all designers' way of working, so that they can achieve the benefit for environment when they design new parts.
Aircraft of the future could be all electric. In other words, all their moving parts could be electrically driven. The intention is therefore to steadily replace the oil-based hydraulic systems in aircraft. In the Copperbird, an electrical test bench, the engineers can test the electric innovations under real conditions. The test facility simulates the onboard network architecture. They show whether the new electric drives can be integrated into the relevant system, where adjustments have to be made, and how robust the electronics are, both in normal operation and in emergencies. The question is, what challenges have to be overcome if aircraft are increasingly to be operated exclusively via electric circuits and servo motors? The simulators can be individually set to any given aircraft type. The Copperbird thus reduces the number of expensive flight tests and at the same time reduces damage to the environment. For the aviation industry, it opens up the way to the green aeroplane.
We faced a lot of challenges in eco-design, but I think that some of the most important challenges were to provide some new technologies which perform equal or better to the conventional one, but mainly those new technologies could improve the environmental impact and perform recyclability. We have many things to cover yet. We have to further mature the technologies already developed, to apply them on more complex demonstrator, more simulated to real parts, and to perform ground and flight testing, long life stability testing like natural exposure testing.
Safety is paramount in aviation. Electrical components reduce weight and thus save fuel, but they also generate a lot of heat. Alongside the question of the effects of high voltages and compact units in the electric systems, the total concept of eco-design focuses on a further important aspect. In the nature of things, this means heat and energy management. On the thermal test bench, the fuselage of an aeroplane is observed in three partial configurations: cockpit, cabin, and tail. The test facility simulates the climatic conditions in the interior and exterior of the aircraft on the ground, in the air, and in failure cases. For example, an extreme loss of cabin pressure, also known as rapid decompression. Thanks to the thermal test bench constructed as part of eco-design, the scientists are able to precisely examine components, materials, and future modular equipment in real scale. The technical readiness level of equipment used in aviation can thus be safely validated on the ground. This lab is unique in the world. It has a number of sophisticated cooling systems, heat exchangers, simulation chambers, and a calorimeter.
So the greatest achievements were to develop these technologies to a certain maturity level, then to manufacture 40 parts, which was quite a large amount of parts, and then to perform eco statements, so air life cycle assessment analysis, to quantify the benefit brought by the new technologies compared to the current technologies. So it was a great achievement of this project. So in the future, we have to continue developing technologies for the production, for green production of our aircraft. And also we have to keep going in the use phase, because the use phase is the most impacting phase. So it's our work since 100 years at Dassault Aviation to reduce the drag, to improve the aerodynamics of the aircraft, to reduce the weight. But we have to continue to work on this area in order to reduce the burden.
By 2020, the partners involved in Clean Sky hope to reduce CO2 emissions and noise per flight kilometer by half relative to the early days of the initiative, and nitrogen oxide emissions by no less than 80%. Eco-design has created ways towards resource efficiency in aviation. The innovations developed here support high-performance flight technologies in the achievement of ambitious emission reduction goals. With respect to EU requirements, however, this is only the start. In order to address the demands of the Eco-Innovation Action Plan, the European aerospace industry needs marketable solutions. In this respect, eco-design has already proved more than successful. The Eco-Design Partnership can look at in pride what has been accomplished. Eco-design is promoting competitive knowledge and skills for sustainability in the excellence base of the European aviation industry. Now the way is open for further progress, and Clean Sky continuation is at full speed. Clean Sky and Eco-Design, a European joint technology initiative whose success is due to the work of many.